Hi, this will be our first math lesson, and I'm not sure where you are in math in school, but I'll try to start with very basic things and go over what we need in order to complete this lesson. And I hope you saw that before, but even if you didn't, it should be simple. So let's start with symbols. If I write a symbol like A in math, A represents some number. I can have A, I can have B, C, etc. So if I want to represent an addition of two numbers, instead of writing, let's say, 2 plus 3, I can write it with symbols A plus B. So A represents 2 and B represents 3 in this case. But A plus B is more general than 2 plus 3 because A and B could be any numbers. So if we assume that we use letters of the alphabet as symbols for numbers, let's go over a few rules that you may know already, but just in case you don't know, let's just review them. For instance, if I have a symbol like A and I multiply it by B, in math we usually write AB. If there is nothing between the letters, that means it's multiplication. Otherwise, we put the actual symbol. If we want to do A divide by B, it will be like this, or plus and minus, naturally A plus B, or A minus B. So those are the ways we do arithmetic calculations on those symbols that represent numbers. Now, what about if I do something like minus A, and I'll write it in parentheses, minus A times B. What is the result of minus A times B? If you know that one of the numbers is negative and the other one is positive, the result will be negative. I hope you know that rule. And if not, now you know it. Minus A times B is minus AB. And if we had numbers, for example, if it was minus 2 times 5, then the result would be minus 10. Okay, let's go to the next example. What about if we have minus A times minus B? In this case, if we multiply two negative numbers, the result is positive. So the result of minus A times minus B is AB. And if we take example from numbers, if you multiply minus 3 times minus 4, the result will be 12. Not minus 12, but 12. So, let's go over another rule. What about if we have A plus B times C? In this case, we have to expand the parentheses, and the way we do it is we multiply C by A, and we add that to the multiplication of C times B. So this will be AC plus BC. Okay, and if we see an example from numbers, we'll see why it's correct. If we have, let's say, 2 plus 4 times 5, let's do it in two different ways. First, let's do it with 2 plus 4. As we know, the result is 6. 6 times 5 is 30, of course. And we'll do it in the other way, which means the way we did it here. So the other way will be 2 times 5, right? Because this is our A, this is our C. So AC is 2 times 5 plus BC, and B is 4 and C is 5 again, so it's 4 times 5, which is 2 times 5 is 10, and 4 times 5 is 20, so this is also 30. So I hope I convinced you that if we put A plus C, A plus B in parentheses, and we multiply it by C, then we can write it as AC plus BC. And here is the proof with this experiment. So now let's do something a little bit more complicated than that. Let's say A plus B times C plus D. And in this case, I claim that we have to multiply each and every element on the left parenthesis with each of the elements on the right parenthesis. And we'll have 4 additions here, because first we do A times C plus A times D, and then we do plus B times C plus B times D. So we're sort of breaking it to twice this kind of multiplication. So the result will be AC plus AD plus BC plus BD. And if we take an example from numbers, let's say it was 2 plus 3 times 4 plus 1. So A is 2, B is 3, C is 4, and D is 1. And let's see what happens if we multiply it in the way we did with the letters. So A times C would be 2 times 4. 2 times 4 is 8, right? So AC is 8, plus A times D is 2 times 1, which is 2. Write it under the AD, plus BC, this is B and this is C. 3 times 4 is 12. And the last element would be BD, which is this times that. So 3 times 1 is 3. And if we add all of them, it will be 10 plus 12, 22 plus 3, 25. Now let's do the addition and then multiplication, because we can add first, because it's in parentheses. Then we have to do the add first of this and the add of this, and then multiply. So if we do that, it will give us 2 plus 3 is 5 times, again, 4 plus 1 is 5, and this is, as we know, 25. So we can see that the result is the same whether we first add and then multiply or we do the multiplication this way. But when we don't have the numbers and it's only A, B, C, and D, we have to do it this way. We cannot take a shortcut because we don't know what A plus B is, we don't know what C plus D is, but we can expand it arithmetically into this. So I hope I convinced you that when you multiply A plus B in parents with C plus D in parents, we get this result where we multiply every element with every element and we add all those multiplications. Okay, so if we know that, let's do something a little bit more complicated. Let's do A minus B times C plus X. Okay, I don't use D, I use X, it doesn't matter. Those letters represent numbers. And let's multiply. So A times C is AC. Then A times X, I have to do plus AX. And then I have minus B times C. Minus B times C, we know that it's supposed to be minus, so it's going to be minus BC. And the last one will be minus B times X, which will be minus BX. Okay, let's do one more, and this will be the most complicated. A minus B times, and if you noticed, I didn't write the multiplication here, because if you don't write any symbol, it means multiplication in math. So A minus B times C minus D. So if we expand that, we'll get AC minus AD. Because if I multiply A by minus D, it's minus AD. And then minus BC is minus B times C. And then the last one, I multiply minus B times minus D. But we know that minus times minus is plus. So the last element will be plus BD. And to convince you, let's do an arithmetic example with numbers. So let's do 3 minus 2 times 5 minus 3. And let's do it first this way, and then we'll do it just simply by calculating the values here and multiplying, and we'll see if we get the same result. So if we do AC, that's 3 times 5, that's 15, and minus AD is minus 3 times, we did this, and minus 3 times 3, because it's 3 times minus 3, so it's going to be minus 9. And then minus BC is going to be minus, and BC are this and this, so it's going to be minus 10, plus BD, and BD are this and this, so it's going to be 2 times 3, 6, and the result is going to be 15 minus 9 is 6, minus 10 is minus 4, plus 6 is 2. So if we do it first with calculating inside the parens, it's going to be 3 times 2, which is going to be 1 times 5 minus 3, which is 2, and we also get the result of 2. So you see that we got the same result here and there, whether we did it this way or we did it first by calculating inside the parens and then multiplying. So that means that this term is the same as this term expanded. Okay, so now that we have all those rules of expanding numbers, we'll deal. Let's go to the problem that I gave you, the quiz, which triggered me to do this lesson, and we'll see how we solve that problem. First, we'll analyze it, and then we'll solve it. So the problem said that there are 35 creatures. Why? Because we said 35 heads. So this is the analysis that we do. We say if there are 35 heads, that means there are 35 creatures. And we say that the creatures are chickens and rabbits. So we know that a chicken has 2 legs, a rabbit has 4 legs. And in the problem it also tells us that there are 94 legs altogether. So now what we'll do is we'll talk about an unknown. We'll mark with unknown the number, let's say the number of rabbits is unknown. And usually the unknown is marked with a letter X. So I'll say that we have X rabbits, and if we have X rabbits, that means that we have 35 minus X chickens, right? Because altogether we have 35 creatures, and if one type of the creatures, the number of them is X, then the number of the other type is 35 minus X. For example, if we had 7 rabbits, then 35 minus 7 would be 28. So we would have 28 chickens. I'm not saying this is the solution. Of course, it's not the solution, but I'm just giving it as an example to show why we can say that if one type of animals is X, the other one is 35 minus X. And after we know that, it's easy to put together something that's called an equation. An equation is 2 terms that are equal one another, and once we put the equation and we solve it, then we can find out what is X, which is the number of rabbits, and if we find out the number of rabbits, obviously we can find out the number of chickens because it's only 35 minus the number of rabbits. So our equation uses the knowledge that there are 94 legs. So what can I do? If I say that there are X rabbits, I can say X times 4 x times 4 means the number of legs that we get as the result of having x rabbits, and the number of legs that we get as a result of having 35 minus x chickens. I know that the chicken has 2 legs each, right? So this is the total number of legs that we have in the yard, and the problem tells us that the total number of legs is 94. So here I set an equation, and the equation uses the unknown x, which is the number of rabbits, and it says number of rabbits times the number of legs that each rabbit has is the total number of legs for the rabbits. The same thing we do for the chickens, and the chickens have 35 minus x of them, and each one has 2 legs, so 2 times the number of chickens is the number of the legs of the chickens, and altogether they all have together 94 legs, as the problem states. So this is the equation, and now let's see how we solve that equation. So if we expand it according to the rules that I showed you before, x times 4 is 4x, and then plus. This is like a minus b times c, right? So 35 times 2 is 70, and then 2 times minus x is minus 2x, and that equals 94. Now, the rule number 1 with equations is that we can transfer elements or terms from right to left or left to right but when we transfer, the sign changes. Plus becomes minus, and minus becomes plus. So what does it mean? If we take the element 70, our goal is to isolate x here and numbers here. Here we see that we have 4x, we have 2x, minus 2x, and we have 70, and here we have 94. So in order to solve this equation, we need to put all the x's here and all the numbers here. So in order to accomplish that, we will take the 70 and we will move it to the other side, to the right side of the equation. But when we move it to the other side, it becomes minus 70. So now we can write the equation as follows. 4x will stay on the left, and minus 2x will stay on the left, but this will be equal to 94, because we have 94 on the right, minus 70, because we took the 70, we transferred it here, but because it transferred to the other side, it had to get minus instead of plus, and this is what we have. So now let's continue to expand on this equation. We'll write semicolon, and then we do 4x minus 2x will be equal to 2x, right? This is straight math. 4x minus 2x is 2x, and 94 minus 70 is 24. So now, if 2x is 24, we want to find what is x. What we have to do, this is the second rule of the equations. We can divide each side of the equation by a number, and that has to be the same number, and then the equation remains an equation. So we divide both sides by 2. If we divide 2x by 2, we get x on the left hand side, and if we divide 24 by 2, we get 12. So this is the solution for the number of rabbits, because we said we have x rabbits. And the number of chickens will be obviously 35 minus 12, which will be 23. So we end up with having 12 rabbits and 35 chickens. So what we did was a two-step solution. The first step was to analyze the problem and to determine an unknown. The unknown we marked as x, which is the normal thing to do in those type of problems. Then we set an equation that describes the information that's given to us in the problem. And this was the equation that we set, because we talked about the number of legs and we knew how to multiply legs times creatures and get the total number of legs. And the second step was to solve the equation, and we used two rules. One rule was moving elements from right to left or left to right. In this case it was from left to right. And we know that the element changes the sign. And then the second rule we used is we divided the equation, each element of the equation, by the same number, and therefore the equality remains, because if this is equal to this, then this divided by 2 will be equal to this divided by 2, because it's the same factor that we divide in. And then we found the solution. So now let's describe a new problem, and we'll see how we solve that problem with the same technique. Let's erase all of this. And this problem is a Ferrari leaves New York City and drives 100 miles an hour toward Pittsburgh. Let's write it in short. A Chevy leaves Pittsburgh at the same time as the Ferrari leaves New York City and drives 50 miles an hour. The distance between New York City and Pittsburgh is 200 miles. Let's suppose that this is a straight road and they both go in the same speed all the time. There are no lights. So this one is going 100 miles an hour and this one is going 50 miles an hour. And the distance, the overall distance between New York City and Pittsburgh is 200 miles. And the question is, after how many hours will they pass one another? Okay, so if we look at this problem visually, we know that they will meet somewhere here. It'll be closer to Pittsburgh because the car from New York City is a Ferrari and it goes faster than the car that comes from Pittsburgh, which is a Chevy. So we know that this place will be closer to Pittsburgh, but we don't know exactly after how many hours they will meet. So let's say the unknown is number of hours to the meeting, and that will be x. So how do we calculate x? We have to think about an equation. So the equation will say that the number of miles an hour, we know that if we have miles per hour in a speed, in order to calculate the distance, how do we calculate distance? Speed times time, right? So if, let's say, the speed is 100 and it's x hours, the distance is 100 times x. For example, if a car goes 100 miles an hour and it goes 2 hours, 2 times 100, the distance will be 200 miles. Right? And if a car goes, let's say, 50 miles an hour and it goes 2 hours, then it will pass 100 miles. So the distance is calculated by speed times the time that that speed is maintained. So the equation that we can put together will be 100 times x is the distance that the Ferrari goes in x hours, and if we add that, in order for them to meet, what needs to happen? This has to pass certain distance, and this has to pass certain distance. We don't know how much distance each one is passing, but we know that the two distances together give us the whole distance between the two cities, which is 200 miles. So that's what it means when they pass each other. When they pass each other, they both together passed 200 miles. And based on that, we can put an equation, because the distance that the Ferrari goes plus the distance that the Chevy goes in X, because X is the number of hours before they pass each other, will give us the total distance between the two cities, which is 200. So this is the equation, and now we have to solve this equation. So 100 times x is 100x, plus 50 times x is 50x. That equals 200. So 100x plus 50x is 150x, straight addition. And that equals 200. So now we use rule number 2 of the equations, and we divide both sides by 150. Why we divide by 150? Because we want to isolate x. In order to have x alone here, if we divide this by 150, we do 150x divide by 150, we can cross the 150, and then we'll have x left. So on the left hand side we'll have x if we divide by 150. On the right hand side, if we do 200 divide by 150, we will get, we divide it by 50, then we'll get 4 divided by 3, or we'll get 4 divided by 3 is 1 hour, plus 1/3 of an hour, right? 4/3 is 1 plus third. I hope you know that from fractions. And 1/3 of an hour is 20 minutes. So the end result will be 1 hour plus 20 minutes. This is after how much time they will meet. And we can check that by multiplying back. If we do 4/3 times 100 plus 4/3 times 50, we should get 200, and I leave it for you as an exercise to verify. This is called verification, that after we found the solution, x equals 4/3, we can put it back in the equation and make sure that we get the correct result. So now I'll leave you a problem that you should be able to solve after watching this video. Maybe you have to watch it one more time, but this is going to be homework. We have a problem with vehicles. We have 30 vehicles. Some cars, some bicycles, and some tricycles. We have 3 times more bikes than we have cars. Altogether, we have altogether we have 30 wheels or tires. Between, no, sorry, this is not so, sorry, we have 80. 80 tires for all vehicles together. How many cars we have? This is what you need to find out. And if you know how many cars we have, you will find out how many bikes you have, because it's 3 times the number of cars. And then you will know also how many tricycles, because then you take the number 30, which is all the vehicles, and you subtract the number of cars, and you subtract the number of bikes, and you get the number of tricycles. So this is the problem. And obviously, you know that tricycles have 3 tires each, and cars have 4 tires each, and bikes have 2 tires each. So try to solve this problem with an equation and let me know what the solution is. You should be able to do it. And if not, if you need some clues, write me an email. So this is it for now. Bye.